Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Instruct, Improving Low-Level Visual Abilities for Multimodality Foundation Models. This research tackles the challenge of enhancing the low-level visual capabilities of multimodality large language models, MLLMs, like GPT-4v, by introducing a novel dataset called Instruct. This figure showcases the improved abilities of a Instruct-tuned LLaVA model on various low-level visual tasks, compared to its baseline version. Let's delve into the core contributions of this paper. While MLLMs have revolutionized visual perception, their accuracy in understanding low-level visual attributes, like clarity, brightness, and noise, remains inadequate. This paper highlights the importance of addressing this gap to empower MLLMs to assist humans in a wider range of visual tasks. This diagram illustrates the data construction pipeline. First, human feedback is collected on low-level visual aspects, forming the Q-pathway dataset. This data is then transformed into instruction response pairs, creating the Q-Instruct dataset, which is used for low-level visual instruction tuning. The Q-pathway dataset is the first of its kind, collecting detailed human feedback on low-level visual attributes. Each feedback includes a comprehensive description of the image's low-level characteristics and an overall quality assessment. This figure shows examples of pathway feedbacks, highlighting their detailed descriptions and overall evaluations. It also presents the distribution of feedback lengths and a word cloud of the Q-pathway, showcasing the diverse range of low-level attributes covered. The Q-Instruct dataset is built upon the Q-pathway, leveraging GPT to convert human feedback into a rich set of instruction response pairs. This dataset includes three key subsets: pathway reasoning, visual question answering, and extended conversations. This figure illustrates the composition of the Q-Instruct dataset, highlighting its three subsets: pathway reasoning, visual question answering, including both what-how questions and yes-no questions, and extended conversations. The paper explores two training strategies for incorporating the Q-Instruct dataset into the training of MLLMs. The first strategy involves mixing Q-Instruct with high-level visual instruction tuning datasets, while the second strategy focuses on a dedicated low-level tuning stage using only Q-Instruct. This figure depicts the two training strategies: mixing Q-Instruct with high-level datasets and conducting a dedicated low-level tuning stage. The paper evaluates the effectiveness of Q-Instruct by measuring the performance of MLLMs on three low-level visual tasks: perception, description, and quality assessment. The results demonstrate significant improvements in low-level visual abilities across all tasks, highlighting the value of the Q-Instruct dataset. This research paves the way for a future where foundation models can effectively assist humans in low-level visual tasks, enabling a more comprehensive and nuanced understanding of visual content. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow researchers. Stay tuned for more exciting academic paper summaries. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.